Alrighty, here's a little video explaining number 5 on our, is it R2? I think it's R2. It's a fan favorite. Okay, so the biggest thing, a few things going on. So I know I have log of the same base. So on the left, log of the same base separated by addition can go to 1 log in multiplication. And I do have this plus 2 as well. And the plus 2, I'm just going to change, I don't want yellow, to log base 10 of 100, because that's what 2 is in terms of log base 10. And so now on the left side, now that I have everything in terms of log base 10, I can make it a single log. So it's log base 10 of k minus 2 factorial, k minus 1 factorial times 100. So again, log separated by addition go to multiplication equals, and the 2 in front of log base 10 of k factorial, I'm going to put up in the exponent. So log base 10 of k factorial squared. Okay, so now, since I have a single log in both sides, on each side, and it's the same base, I can set the insides equal to each other. Okay, so this means then that k minus 2 factorial times k minus 1 factorial times 100 equals k factorial squared, or k factorial times k factorial. All right, let's write out what this means, because you're going to find a lot of stuff is canceling here. So k minus 2 factorial means k minus 2 times k minus 3 times k minus 4 all the way down to 3, 2, 1. And then k minus 1 factorial, so you'd be multiplying this by k minus 1 factorial, which is k minus 1 times k minus 2 times k minus 3, all the way down to 3, 2, 1. And then, and you have this 100. So this is the left side, and the right side is equal to k factorial, and it's squared. So I'm going to have, it's going to be equal to k squared times k minus 1 squared, k minus 2 squared, k minus 3 squared, all the way down to 3, 2, 1. That's just doing k factorial and then squaring each piece. Okay, on the left, notice we have a lot of repeats. So I've got this k minus 1, which only occurs once here on the left. So it's going to be k minus 1. And I also have the 100, which only occurs once. But then I've got k minus 2, k minus 2, k minus 3, k minus 3, all the way down to 3, 2, 1. So I actually have 100 times k minus 1 times k minus 2 factorial squared, right? Because I have k minus 2 squared, k minus 3 squared, k minus 4 squared, k minus 5 squared, which is just k minus 2 factorial squared. Okay, and then on the right side, I have this k squared, k minus 1 squared, and if I take all the rest, that's just k minus 2 factorial squared, which is nice because that'll cancel with the left. Then one of the k minus 1s goes away, so I've got 100 equals k squared times k minus 1. And now I don't want to distribute the k squared, because then I have a 3rd degree, and that's not going to help me too much here. So I'm going to look back to the directions, and it says that k is an integer and it's greater than 2. So I'm going to start guessing checking. If k equals 3, I'd have 3 squared times 3 minus 1 times 2, which doesn't equal 100. If k is 4, I've got 4 squared times 4 minus 1, which is 3, which doesn't equal 100. If k is 5, I've got 25 times 5 minus 1, which, bingo, equals 100. So k equals 5. There we go.